Hi, everybody, and welcome back. Today we are going to be going over Lesson 3 from Unit 3, which is a continuation of our study of implicit differentiation. So in the previous video, we learned how to find the derivative of an implicitly defined function using the chain rule. Today we're just going to continue to talk about that. Our learning target has not changed. We can calculate the derivative of an implicitly defined function by applying the chain rule, which is the reason that we write the dy over dx every time we take the derivative of y. Today, we're just going to be looking at this through a new lens. And the first thing we're going to do today is we're going to find the second derivative using implicit differentiation. So at the beginning of this unit, we learned that the second derivative is just when you take the derivative again. So it's the same thing here. When we want to find the second derivative in terms of x and y, what this means is that your final answer should just have x's and y's in it. And that's going to become important in just a second. So just keep that in mind. You want your final answer to have x's and y's in it. The first step is to find the first derivative, if necessary. So sometimes the first derivative is already provided. We've seen examples like that before, and we can see another example like that here at the bottom. Problem number 2, we're already given the first derivative. But if we don't have the first derivative, then step 1 is to find the first derivative. The second step is going to be to find the second derivative by differentiating again. Now, your second derivative is probably going to have a dy over dx in it. Now, what you need to do is you need to substitute dy over dx back in to create an equation that only has x and y. And the reason is because, remember, we want our final answer to just have x's and y's. So let's go through an example so you can see what we're supposed to do here. For problem number 1, it says find the second derivative, d squared y over dx squared, in terms of x and y. Step number 1 is find the first derivative. So the first derivative here would be 9x squared minus 6y, and then don't forget to put times dy over dx because we're taking the derivative of y, equals the derivative of 8, which is 0. Once you've got that figured out, our next step is to get dy over dx by itself. So I'm going to start by subtracting the 9x squared, which means I have negative 6y times dy over dx equals negative 9x squared. And then I would divide by negative 6y, so dy over dx equals negative 9x squared divided by negative 6y. Now I have a helpful hint for you, which is I would simplify this and reduce that fraction as much as possible. So since the 9 and the 6 are both negative and both divisible by 3, this fraction reduces to 3x squared over 2y. Now that's my first derivative. That's kind of like step 1 of the process. Step 2 of the process is going to be to find the second derivative. So now we're going to start with this problem. So we know that dy over dx, the first derivative, is 3x squared over 2y. The second derivative, so d squared y over dx squared, is going to be, we're going to need to use quotient rule here because this is a fraction. So I'm going to have low, copy the low, d high, so 6x, minus high, so 3x squared, d low, so 2, and then dy over dx because you took the derivative of y, and then low squared goes down below, 2y squared. Okay, so now we've got the second derivative, but what you'll notice is that we have a dy over dx in our equation. We do not want a dy over dx in our final answer. We want only x's and y's. So what we're going to do is take this equation for dy over dx and we're going to substitute it into here. What that means is that our new second derivative would be, and I'm going to simplify a little bit here as I go. So 2 times 6 would be 12xy minus 3 times 2 would be 6x squared times 3x squared over 2y all over, and 2y squared would be, if I multiply that, 2y times 2y would be 4y squared. Now, that is okay as a final answer. We're done. However, the one thing that I would like for you guys to do in order to make this look a little bit better, and because generally on the AP test, this is not how they'll leave the final answer, they're going to end up simplifying, is we want to get rid of this denominator. So in order to eliminate that denominator, we're going to multiply through by 2y on the top and then 2y on the bottom. So on the top, we're going to multiply everything by 2y, and on the bottom, we're going to multiply everything by 2y. Now, when you distribute, 2y times 12xy is 24xy squared. Now, in this term, the 2y on the bottom and the 2y we're multiplying by cancel. So we're just going to have negative 6x squared times 3x squared makes negative 18x to the fourth. And all the way in the denominator, we're going to have 4y squared times 2y is 8y cubed. And that's your second derivative. So just kind of a little bit of algebra-ing there at the bottom to make sure that it looks a little bit better. So by the way, this was the third step, which was to substitute in the dy over dx so that you only have x's and y's. Okay. Now, let's take a look at a follow-up question. So this problem is going to say, consider the differential equation dy over dx equals y squared over x minus 1. So the first step is going to be to find the second derivative in terms of x and y. So we've already got the first derivative, now we want the second derivative. The second thing, though, is it says write the equation for the tangent line. Now, this is going to be a review problem. We've talked a lot about tangent lines already this year. However, this is now going to be a tangent line problem in the context of an implicitly defined function. So I just want to make sure that we're still connecting. The derivative is still the slope of the tangent line. It's just that now the derivative is a little bit different when we have to actually find it ourselves. So for problem number 2, let's start with the second derivative. In order to find the second derivative, we're just going to take the derivative of this equation, which means we're going to have d squared y over dx squared equals, we're going to need to use quotient rule. So I'm going to copy the low, x minus 1, d high, so 2y, and then dy over dx, minus high, so y squared, d low, which is 1, and low squared goes down below, so x minus 1 squared. Okay, now what you'll notice here is, just like before, we have a dy over dx in our equation. And since we want our answer to only have x's and y's, we're just going to substitute our known formula for dy over dx into this equation. So my new fraction is going to say, and I'm just going to simplify a little bit as I go, I'm going to put the 2y at the beginning of this term so it looks a little bit neater. And then instead of dy over dx, I'm going to have y squared over x minus 1 minus y squared all over x minus 1 squared. Now, in this problem, if you look at what we have, the x minus 1 here and the x minus 1 here cancel because one is being multiplied and one is being divided. So my simplified second derivative would be 2y times y squared would be 2y cubed minus y squared over x minus 1 squared. And there's your second derivative. Okay, as a follow-up question, if a problem says write the equation for the tangent line, I want to remind you that one of the ways we can help ourselves to organize our work is we can list out the information we need. We need a point, we need a slope, and once we have those things, we can write the equation of our tangent line. Now, the point here is actually given to me in the instructions. It says that f of 1 is equal to 2. So the point that I'm working with here is 1 comma 2. To find the slope, I need to use my dy over dx equation because that means derivative. And the slope of a tangent line is the derivative of the function. Now I want to evaluate this at my given x and y values. So I'm going to substitute those in. And here's how I show that I'm substituting those in. If you draw this vertical line in mathematics, it means evaluated at. And then you just put the numbers you're plugging in at the bottom, 1 comma 2. Again, notation is really important, so please make sure that this is something that you continue to do to show your work. If I plug in the x is 1 and the y is 2, I get 2 squared on the top, and then 1 minus 1 on the bottom, which means I get 4 divided by 0. Now, 4 divided by 0 means undefined. If we have an undefined slope, that means that we have a vertical line. And that means that the equation of that line is going to be just x equals whatever the x value of that ordered pair is, in this case, the 1. So there are a couple things I want to make sure you guys really pull out of this problem. The first thing is that the setup is the same as it always has been, point, slope, tangent line. The second thing is that we use the derivative to find the slope. And the third thing is that when you have an undefined slope, it must be a vertical line, which means the equation is going to be x equals. If it was a horizontal line, it would be y equals. All right, last but not least, let's talk about problems that have different variables. So we know that we should use implicit differentiation when the y is not isolated. But it's also important to recognize when we need to use implicit differentiation when other variables besides x and y are used. So oftentimes, these problems are going to be presented in a context. For example, h in this problem might stand for height over time. If you look at this equation, you can tell that in this problem, the output variable, or the y, is the letter h because it's on the top. And normally we would write dy over dx. And you can tell that the letter t is kind of like the x variable, the input variable. Because the h is acting like an output variable, you can see that this is kind of like having a y built into the equation. It's really important that when you look at your notation, you make a note that the top variable is the output acting like y, and the bottom variable is the input acting like x. The reason that that's so important is that as soon as you see a y or output variable, you need to write dy over dx or dh over dt to show the derivative. So an example where you might see something like this is, suppose that dh over dt is equal to 3 parentheses 4 minus h, find d squared h over dt squared. The first thing I would note here is that the h is like the y in this problem, and the t is like the x in this problem. What that means is that we need to use implicit differentiation because this h is like having a y that is not isolated. Now, there are a couple things that we can do to make our lives easier here. Now that I know I need to use implicit, that's step 1. Step 2 is I can actually make my life a little bit easier here by just simplifying the equation before I start. So I would distribute the 3. So dh over dt, again, I'm not taking the derivative yet, I'm just simplifying, would be 12 minus 3h. Then I would take the derivative. So the second derivative, d squared h over dt squared, would equal. The derivative of 12 is 0. The derivative of negative 3h would be negative 3, and then times dh over dt. Just like you would usually write dy over dx, now we just need to write dh over dt. Now what you'll notice is that you've got this dh over dt here. So we need to substitute in the original equation so that our final answer only has h's and t's in it, which means that I'm going to have d squared h over dt squared equals negative 3 parentheses 3 parentheses 4 minus h. Now you can simplify this lots of different ways. You could leave the answer like this. You could, what I usually do is I multiply the negative 3 and the 3 together and I just get negative 9. And then I would just leave the parentheses 4 minus h. You could, if you wanted to, distribute completely, in which case you would get negative 36 plus 9h. That would be fine. You can write it either way. It's just kind of up to you where you feel comfortable stopping. So what does this look like in a context? Problem number 4 says the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams at time t days after it is first weighed, then db over dt is 1/5 times 100 minus b. Now, in this problem, what I would do first is I would quickly note that in this problem, the b is acting like the y and the t is acting like the x. So right away, I'm going to go, hey, wait a second. There's a y that's not isolated. I'm going to need to use implicit differentiation, which is going to be relevant when we do problem part B here, where we have to find the second derivative. For part A, it says, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? So this is telling me the B values, the weight, because it tells me here B of T is the weight. So 40 grams is B, 70 grams is B. I want to know, is this gaining weight faster? So I want to know the rate. Well, the rate is the same thing as the derivative. It's the slope, or how fast it's happening. It's the rate of change. So in order to figure this out, I'm going to find the rate of change when b is 40, the rate of change when b is 70, and I'm going to see which one is bigger. So let's start with finding those values. First, I'm going to find db over dt when b is 40, which would be 1/5 times 100 minus 40, which is 1/5 times 60, which is 12. Then I'm going to find dB over dt, the rate when b is 70, which would be 1/5 times 100 minus 70, which is 1/5 of 30, which is 6. So if I want to know which one is when the bird is growing fastest, it's going to be when the weight is 40, because 12 is bigger than 6. For explaining my reasoning here, I'm just going to say that. So I would say the bird gains weight faster when it weighs 40 grams because, and then I'm just going to state my reasoning, because the rate dB over dt evaluated when b is 40 is bigger than the rate dB over dt evaluated when b is 70. In math, your reasoning can just be the mathematical reason. You don't have to kind of write it in words. You can just use the symbols to show that. Just remember that this inequality means that this one's bigger than that one. The second part of this question says, find the second derivative. Now, this is where recognizing that b is acting like a y and is not isolated is going to be really important. So the second derivative here, I can make my life a little bit easier by distributing. So just like in problem number 3 up at the top, I'm going to distribute here, and 1/5 times 100 is 20 minus 1/5 b. Then I'm going to actually take the derivative. So d squared b over dt squared would be, the derivative of 20 is 0, so just negative 1/5 and then dB over dt, because anytime you take the derivative of a y, you need to attach that as the chain rule. Now I'm going to substitute. Instead of dB over dt here, I'm going to fill in the original equation. So the third step here would be d squared b over dt squared equals negative 1/5 times negative 1/5. Oops, sorry, positive 1/5. I can copy. Times 100 minus b. And last but not least, you can simplify this. You don't have to, but what I usually do is multiply the negative 1/5 and the 1/5 together. And so I would have negative 1 over 25 times 100 minus b. You could distribute fully, which means you would have negative 4 plus 1 over 25b. Any of those answers are acceptable. Can go with any of them. All right, that's it for today. Thank you guys so much for watching, and I will see you for some practice soon.